In this video, we'll cover Chapter 5, using equations to solve business problems. Section 1 talks about solving basic equations. Before we can solve basic equations, we want to review a couple key terms that we'll be using. So an equation is any mathematical statement that has an equal sign. Okay, an expression does not have an equal sign. So that's how you can quickly tell the difference. An equation has an equal, expression does not. Variables are also known as unknowns. So that's what we are trying to solve for. Constants, or the knowns, are parts of an equation that have been given to us. Terms are the constants and the variables of an equation. So in the equation in your book, it says x plus 7 equals 10. X, 7, and 10 are our terms. Solve an equation means to find the numerical value of the unknown. And the solution, or the root, is the numerical value. So in solving equations, we're going to use basic operations, addition, subtraction, multiplication, and division. So we need to know how to go about solving them. In order to do that, we need to look at several examples. So in your book, it starts off here up at the top of page 125. We're looking at a term, the multiplication of 5 times y. So it can be written all these different ways here. The number 5 in the term 5y is the coefficient. So if there is no number indicated and it's just written as y, then the coefficient is understood to be 1. They've used 1w equals w. So division in equations is indicated by the fraction bar. So 5 divided by y is written as 5 fraction bar y. It's important to remember that an equation is a statement of equality. Remember, it has the equal sides, the equal sign. Then your text goes through what it calls when we want to transpose something from one side to the other. And in order to do that, you have to do the opposite operation. A lot of times it's easier to see this done in action than to read about this. But let's just review that the opposite of addition is subtraction. Subtraction, the opposite is addition. Multiplication and division are opposites. Your textbook does list the steps for solving equations and proving the solutions, which I think you will find helpful. And it does go over some examples. If you look at example 1, solve the equation x plus 4 equals 15, prove the solution. So all we've had to do here is subtract 4 from each side. We get x equals 11. You can prove it by doing 11 plus 4, which was the opposite of what we did. We subtracted 4, and you get 15. So right now I'd like for you to pause this video and do the try it exercise 1. Solve both of these equations, and then come back to the video. At this point, you should have checked your answers with the solutions on page 147. We will move on to the second example. So this example says solve the equation h minus 20 equals 44. So remember that we're always going to do the opposite. If it says minus 20, we're going to add 20 to each side. Add 20 to each side, we get h equals 64. We can prove this. We simply replace the h with 64. 64 minus 20 is 44. 44 equals 44. So now it's your turn. Try it exercise 2. Try to solve these two problems and then come back to the video. Okay, you should have checked your answers on page 147. As always, you can email me with any questions or concerns, and I am always happy to help. Now we are dealing with example 3 and 4. We're going to do these together, and then you can try both of these together. So 3 deals with multiplication. 9 times t equals 36. To get that t alone, we have to do the opposite of multiplication, which is division. And whatever we do to one side, we must do to the other. So we've divided each side by 9. You get t equals 4. Then they do the proof of checking their work. And it does come out correctly. Then in example 4, we're looking at division. Excuse me. The equation m divided by 5 equals 4. So since we are dividing, we're doing the opposite. We're going to multiply each side by 5. So you can see right down here, you get m equals 20. Again, they've done their proof, which is the checking step of your work, and it does check out. So pause the video right now. I want you to try it exercise 3 and try it exercise 4, and then come back to the video. Okay, you should have checked your answers with the solutions on page 147. Hopefully everybody is doing so well so far. Do not give up on this. With some practice, this will get easier. So now we're going to take a look at examples 5 and 6. These are slightly more complicated. They just have one more step. That's it. So don't get overwhelmed. We're going to start with this first one. Example 5, solve the equation 7r minus 5 equals 51 and prove the solution. So this has subtraction and multiplication in it. We always have to do the order of operations. So we are going to go ahead and get this 5 over to the other side. And the way we do that is we're going to add 5 to each side. That's the opposite of subtraction, addition. We get 7r equals 56. 7 times r, so we're going to do the opposite of that for our next step. We are going to divide each side by 7. We get r equals 8. Then we're going to go back. We're going to check our work and prove the solution by putting 8 in for r. 7 times 8 minus 5 does in fact equal 51. Pause the video, do the try it exercise number 5 right now. Let's see how we do. Okay. You should have checked your answers on page 147. We'll move on to example 6. So this one is x divided by 2 plus 20 equals 34. The first thing we're going to do is we are going to subtract 20 from each side. That leaves us with x divided by 2 equals 14. Since it's division, we do the opposite. So we're going to multiply. Multiply each side by 2, x equals 28. On the next page, page 129 now, we're looking at the proof. We have to prove it. We're going to replace x with 28. Solve it. 34 equals 34. We're good. So go ahead and take a minute and do the try it exercise 6. Okay. Did you check your answers on page 147? Hopefully. And hopefully you got the correct answers. If you didn't, take a moment, compare your work to their solutions, see if you can figure out your mistake and correct it. All right, we're going to move on to parentheses and talk about them and look at an example with that. So parentheses are used in equations, and they can mean different things. So an example that they've given here is 5 parentheses, 3 times x plus 6, close parentheses, equals 20. So when we're solving equations, parentheses need to be removed before we can do any other operations. So in order to remove the parentheses in the example that they've given us, we have to multiply the coefficient by each term inside the parentheses. So some of you may have remembered this as distribution. So we have to distribute the 5 to each of the terms inside the parentheses. So what we end up with is 5 times the quantity 3x plus 5 times the quantity 6 equals 20. And then we take that one step further and we multiply 5 times 3 and we get 15, and we bring down the x, plus 5 times 6 is 30 equals 20. So now let's take a look at example 7. Example 7 says solve the equation 8 parentheses 2k minus 4 close parentheses equals 48. So the first thing we're going to do is we are going to distribute this 8 over each of the terms inside the parentheses. And we get 16k minus 32 equals 48. So now we're at a place that we've dealt with before. We come down here, we simply add 32 to each side. We get 16k equals 80. Then since it's 16 times k, and we want to isolate the k and get that alone, we're going to do the opposite and divide. Divide each side by 16, we get k equals 5. We check our work, and it comes out correctly. Now I'd like for you to try it exercise number 7. Try it exercise 7. Pause the video, do that work, and let's see how you did. Okay, you had a few minutes to do your work. Check your answers on page 148 and verify that they are correct. The next thing we're going to talk about is when we have an unknown or a variable more than once. Do not let this freak you out. All we have to do is find a way to combine them. So when you look at the steps here on page 130, step 1, to combine unknowns, they have to be on the same size, okay? If they're not, you have to move it to the same side. So in this one, it's 5x equals 12x plus 2x. In order to bring the 2x to the other side, you have to do the opposite. So we're going to subtract 2x from each side, which is how they got this. 5x minus 2x equals 12. Then we're simply going to add or subtract that together. So in this case, 5x minus 2x is 3x equals 12. And then we can solve from there. Then we would divide each side by 3, x equals 4. So let's take a look at example 8. We have solved the equation 4c plus 7 minus c equals 25 minus 6c, and prove the solution. So they've given us 3 c's here that we need to combine together. So the first thing we're going to do is, if we already have these variables on the same side, we can just combine them. So what they've done is they've taken this 4c and subtracted c, which is like subtracting 1c, leaves us with 3c. So they've rewritten it 3c plus 7 equals 25 minus 6c. Then we want to get the c's together. It doesn't matter which way you take it. So they've decided to add 6c to each side. Then you get 9c plus 7 equals 25. Then we're going to subtract 7 from each side. We get 9c equals 18. So 9 times c, we do the opposite. We're going to divide each side by 9. We get c equals 2. Then down here we do our proof to check our work, and it comes out correctly. Now I'd like you to take a few minutes, do the try it exercise 8, and then come back, and we will continue on. Okay, so how did that go? Hopefully well. Checked your answers on page 148. Made any corrections if there were any issues. We will continue on.